Hello, everyone. My name is Jaemin, and I'm a PhD student at the University of Michigan. And today I'll be presenting our work on synthesized social signals. And this is work done with awesome co-authors Sonali, Eshwar, Tyler, and my advisor, Eric. I would like to start off by asking a question to the audience. How do you decide whether to interact with a stranger online? Let's say a stranger DM'd you on Twitter. How do you decide whether you want to reply back? And I think in many of the cases, we rely on social signals on social platforms. Social signals are perceivable traits or features that indicate presence of hidden qualities. And in face-to-face interactions offline, the way we dress, the way we talk to people, our facial expressions are all social signals which we use to express ourselves and which we use to make decisions about others. And it's similar in social platforms. This image illustrates some major examples of social signals on social platforms. For instance, the profile image, cover image, work information, school information, bio, number of friends, list of friends, etc. are all major examples of social signals which we use to express ourselves and which we use to make decisions about others. And prior work in many fields have shown that social signals do matter in online spaces as well. People manage self-presentation using them, and such self-presentation does affect people's perception of one another. So in short, social signals do matter in online spaces as well. However, many of them are limited compared to the ones in face-to-face offline interactions. First, the kinds of social signals are limited to the ones platform designers have provided through the interface. So for instance, this is my Twitter profile page, and the way I can express myself is limited to what Twitter has provided me. And this is in contrast to the many nuanced ways, such as facial expressions, which we use in offline interactions to express ourselves. And furthermore, I think this is more critical. Many of them are very easy to fake. So for instance, I can always swap my profile picture to Eric's profile picture. And although it does look strange, I think this example illustrates that it's very easy to do it. You can easily arbitrarily upload any kind of image, type any kind of text in many of the social signals on social platforms. So in short, many of them are conventional social signals, which means there's an arbitrary link between the actual hidden quality and the perceivable trait. So I guess I've been so far talking about things that social platforms aren't good at. But this paper actually started off by focusing on something that social platforms are better at than offline interactions. And that is, they provide an important source of information much more easily compared to the offline world. And that is a history of a person's behavior. So in offline, a history of a person's behavior isn't visible. And an example I really like is that when I first joined the PhD program, it took me a while to get to learn how Eric previously interacted with his prior students before me. Because the history of interactions isn't visible, it takes time to know them. In contrast, in online spaces, when you go to someone's profile page and scroll down, you can see past comments, posts, and tags, which are all a history of a person's behavior. So why don't we use this abundant source of information when interacting with people? The problem here is that it takes a lot of time and energy to peruse through a list of past posts and to synthesize information. Imagine yourself scrolling down on Twitter. You probably don't want to spend a lot of time reading tens, hundreds, or thousands of posts and reaching a conclusion, right? So to address this gap, we introduced a new concept called synthesized social signals, in short S3s. S3s are social signals computationally derived from an account's history and then rendered into the profile. And while many work has focused on computationally modeling accounts, in this work, we also emphasize rendering those results into the profile so people can see them. And S3s have two major characteristics. First, they reduce cost to access important information. Again, as I've mentioned, because we're bringing those computation results to the profile page where people can see them, they become much more accessible. And furthermore, they are harder to fake compared to the current social signals. As I've mentioned, many of the current social signals are easy to fake because you can arbitrarily type any kind of information or upload any kind of image. But because S3s are based on a long period of time, in theory, sure, a person can delete every post and start from scratch. But in reality, a person would have to manipulate many posts to successfully manipulate S3s. And I would like to illustrate how S3s work by showing a scenario of Bob. So let's say Bob is an account that has been posting pretty toxic posts. And Bob has also been posting misinformation online. And these posts pile up and are fed to algorithms which conclude that Bob is likely to be a toxic and misinformation spreading account. And these results are, these algorithms results are rendered onto Bob's profile page so people can see them and make decisions about Bob. So for instance, the profile border color changed to red, and people can see tags of toxicity and misinfo attached underneath Bob's username. So people can see these and make decisions about Bob. So far, I've introduced the concept of S3s, but in our work, we also built a system called SIG to actually test how S3s work in real-world platforms. And SIG is an extensible Chrome extension, and for those that don't know what Chrome extension is, it's a piece of software that augments on top of existing websites in Chrome. So for SIG, it works on many social platforms in Chrome, and you can embed any kind of algorithms to derive different kinds of S3s. But for our field study, we focused on Twitter, and we focused on toxicity and misinformation because we thought these are two well-known problems on social media. And before I talk about some interesting results we found in our field study, I want to provide a clear picture of how SIG works. So I'll first talk about a user scenario based on participants' real experiences. So let's say I logged onto Twitter and I see a new account called Lucy started to follow me, and she even liked one of my retweets. At the same time, I noticed that SIG flagged Lucy by coloring her profile border color to red. Curious, I click on Lucy's image and see that SIG has flagged Lucy as toxic and a misinformation spreading account. And this is surprising because Lucy wrote in her bio that she's also a PhD student focusing on HCI. But thanks to SIG, I decide not to follow back. And so this is a simple user scenario of how a person can use SIG. And I also want to talk about how SIG's algorithms work because I think there might be some people curious about it. So how SIG works is that when it scans an account, it retrieves up to 200 recent posts of the account. And for toxicity, SIG runs Perspective API per post, and Perspective API is a machine learning-based API that outputs various toxicity-related scores, and it's built by Google. And based on multiple pilot testings, we concluded that the final toxicity score for the S3 is the proportion of posts that have met the following 3 criteria. And for misinformation, again, per post, SIG parses links and checks if the domain is included in open sources dataset, which is a dataset curated by researchers that include domains of websites that spread misinformation. And so the final misinformation score is the proportion of posts that include at least one link with domain among the open sources dataset. And as I mentioned, SIG works on profile pages, and participants were able to adjust the thresholds for toxicity and misinformation because we thought everyone's thresholds are different. And participants were able to click on the tags of toxicity or misinformation, which then shows a pop-up showing the scores and also up to 5 most toxic or misinformation spreading posts. And so this pop-up kind of hinted at the reason why SIG was flagging accounts. And as I've mentioned, SIG also works on notification and timeline pages, and SIG communicated the results through the color of the profile image border. So when the color turns blue, when the border color turns blue, it means that SIG is currently computing. If it fades away, it means SIG concluded that the account is likely to be safe to interact with. If it turns red, it means SIG flagged the account for a reason. And so I hope these descriptions help everyone to have a clear picture of how SIG works. And now I'll move on to our field study. So we recruited 11 people from Twitter by tweeting and using Twitter ads to promote our tweets about the study. And we asked people to install SIG and browse through Twitter just like they do in everyday life. And we used online survey and interviews to understand their experiences. And while the survey results show that people were overall positive about their experiences, I want to talk about our findings from the interview. I think the most interesting finding was that S3s contravened conventional social signals. So for instance, one participant encountered a politician that had a blue verification checkmark. And I think many of you know that verification marks are used in many social platforms to indicate a credibility. But SIG actually flagged that account as misinformation spreading. And this participant thought it was funny, but at the same time, he said it made him realize that this politician has an agenda she's pushing. And it wasn't just verification marks. And some participants said they noticed SIG was flagging accounts with high number of followers. And people tend to think high-profile accounts are legit, but when SIG accurately flagged them, participants said it made them realize to rethink about those accounts. And next, a few participants said they felt safe as a result of using SIG. And not surprisingly, many of them, all of them actually, were women and non-binary people who tend to experience online harassment more frequently. And so this participant said that they would keep the threshold for toxicity of SIG low so that it can flag as many accounts as it can. Next, a lot of participants use SIG to make social decisions, which means that many of them were using SIG to decide whether to mute, block, or follow accounts. And keep in mind that we didn't tell them to use SIG in such way because we didn't want to bias them, and we thought it was unethical to tell them to go look after toxic or misinformation spreading accounts. But despite us not telling to do so, many of them use SIG to mute or block or decide whether to follow accounts. And last but not the least, many participants said they thought SIG was useful in saving time and energy to understand accounts in a better way. So for instance, this participant said, the extension would be a useful way for me to quickly get information without having to scroll back a zillion pages. And we also asked participants about their thoughts about people's communication if Twitter actually implements S3s. So the participants use SIG, but what if Twitter actually implements S3s? How would people's communication change, or maybe it won't change at all? And what participants said was that some of them were optimistic. They thought it would definitely tackle the problems of toxicity and misinformation online. At the same time, some people had mixed thoughts because people would always find ways to transverse the system, and there's always the issue of algorithmic bias. I think our work shows that tools like SIG give people the agency to make decisions by showing them the results of computation. But at the same time, there's limitations because algorithms aren't perfect. So I think one line of future work that will be interesting is to build tools like SIG that use human in the loop to quickly address false positives and false negatives. And I would like to end my presentation by saying that I think our work shows surfacing results of computation gives people the agency to make their own decisions, and people are generally interested in such opportunities. And thank you.